Water. Life began in it, and it covers our planet. There are 1,398,898.3 times 10 to the third kilometers of water on Earth, and a great deal of that water is frozen. We refer to the frozen water of Earth as the cryosphere. The National Oceanic and Atmospheric Administration, or NOAA, defines the cryosphere as all the solid frozen water on Earth. It's found in places that are subject to temperatures below 32 degrees Fahrenheit for at least part of the year. The components of the cryosphere include ice and snow, ice caps, glaciers, and permafrost. Really, any frozen water is part of the cryosphere. NOAA also says, the components of the cryosphere play an important role in the Earth's climate. Snow and ice reflect heat from the sun, helping to regulate our planet's temperature. Because polar regions are some of the most sensitive to climate shifts, the cryosphere may be one of the first places where scientists are able to identify global changes in climate. Climate is the observation of changes in temperature, weather, and other variables over the course of decades. By comparing records from paleoclimate reconstructions, it has been concluded that since 1950 there is unequivocal evidence that the climate is warming. Due to the increase in greenhouse gases, the climate is going through a rate of warming faster than any previous warming periods on Earth. This increase in greenhouse gases has been attributed to the drastic increase in carbon dioxide emissions from fossil fuels. It has been measured that since 1750, carbon dioxide concentrations have increased from 278 to 390.5 parts per million as of 2011. There is much evidence showing that this increase in carbon is from anthropogenic sources. This increase began with the Industrial Revolution, as humans increased reliance on fuels that release greenhouse gases such as carbon dioxide when they're combusted. With this drastic increase in carbon dioxide concentration, the globe is experiencing unprecedented amounts of warming. Glaciers and other forms of ice collectively comprise a massive storage holding 68.7% of Earth's fresh water. 10% of Earth's land is covered by glaciers. In the U.S. alone, glaciers cover over 75,000 square kilometers. Albedo is a measure of the reflection of solar energy. Solar energy contributes greatly to global warming and therefore climate change. Ice and snow have high albedos, meaning that they reflect a lot of solar energy. All the glaciers and frozen surfaces on Earth contribute to combating the rising temperatures. However, the ice is melting because of the increased global temperatures. The 2013 IPCC report stated that even if the temperatures stop rising, it is very likely that the ice will continue to melt. This current melting and possible future melting have serious impacts on the global oceans. The ocean plays a role in the cryosphere by serving as the world's regulation system. It stores ice in its liquid form as a way of maintaining temperature equilibrium not only in the water but also in the air. This process is done through the circulation of ocean currents. Spread throughout the entire ocean is a current system known as the ocean's conveyor belt. It circulates warm and cold water around the globe based off a number of different factors such as density, salinity, and the temperature of the water. However, this process can be thrown off-kilter if large amounts of cold or warm water are introduced in the wrong location, such as massive influxes of melted ice water. The oceans are also experiencing sea level rise. Sea level rise is a direct effect of the melting glaciers and ice sheets around the globe. Since both ice sheets and glaciers are land ice, their melting only contributes volume to the ocean. In addition, the global mean sea level is changing due to thermal expansion of the water, because as things heat up they expand, meaning that the already existing volume of the ocean will take up more space, flooding the coastlines. Antarctica. It seems that whenever politicians, scientists, or the media want to talk about how global climate change, or more specifically global warming, is affecting the Earth, they mention Antarctica. And they aren't wrong to. Although the eastern ice sheet of Antarctica is indeed gaining mass, the western ice sheet is where the trouble is. Robert Thorson, professor of geoscience at the University of Connecticut, wrote, "The edge of the Thwaites Glacier is thinning and retreating back to the bedrock ridge that pins it in place. Once inside this threshold, the entire West Antarctic ice sheet will disintegrate, raising global sea level by 10 feet. The plug has already been pulled. The global drip will continue until the thaw is complete." Some people will claim that there is nothing to worry about, as the melting of Antarctica has happened before. And yes, 750,000 years ago, the West Antarctic ice sheet did completely melt, causing sea levels to rise dramatically. But in our day and age, we have increasing temperatures and drastic changes to the climate, hugely influenced by humans. With the anthropogenic impact, it is more and more unlikely that Antarctica will ever be able to gain enough mass to counteract the sea level rise.